Hello students, in chapter 7 transport layer, our topic is congestion control. We know TCP is a end-to-end protocol and we say TCP is responsible for process to process reliable delivery. For reliable delivery means the TCP have the solutions for all the lost packets, corrupted packets or duplicate packets and also give the in order delivery of the segments to the upper layer process. So congestion control will also play a role in the combination of flow control here. So mainly it is not always that congestion will occur at the process or at the transport layer. Maybe many other sources are also responsible for the congestion. Let's see how this congestion control is happened in the transport layer and how or what are the solutions we have for this congestion control techniques. So let's see. Mainly TCP is an end-to-end protocol. is an end-to-end protocol means end-to-end connectivity is given by the TCP. End-to-end connectivity, and this one is using the services of IP protocol of the network layer. And we know IP protocol is a connectionless protocol. IP protocol is a connectionless protocol means there is no path between the source and destination. Packets of the IP protocol can choose any path to reach the destination. Just packets are released by the sender in the network, and it's depend on the packets or between the network devices like routers, how they will take a decision on the basis of routing table and forward the packet on which direction. Okay, so TCP cannot ignore the congestion in the network. Mainly this congestion will not occur only in the sender and the destination. This one can also possible between the sender and destination network. Like here, this is our sender and this is our receiver, and between this sender and receiver we have two routers. Router 1 and this is router number 2, and they are connected through these routers. Mainly routers have the limited buffer size, and here these routers may be connected through some other different networks also. The packets are coming from all the networks. To the router limited buffer will get full and router is not able to accept more packets. Because of that one, some packets are get dropped and these packets are get lost. For these packets our receiver will wait, but receiver will not get these packets or not received by the receiver. Receiver will send the acknowledgement for the packets. Already so many congestion in the network or so many traffic in the network, and from here receiver is also not getting the packets, then this one also start to sending the acknowledgements, means already traffic and some more traffic will come. This will create a congestion in the intermediate network, and more packet get lost, more and more packets lost means more and more retransmissions. These retransmission may be possible due to the packet lost or due to the timeout expire at the sender side. Maybe any possibility. If packets are dropped by the router because of the buffer capacity, then that packet is get lost. Receiver will not get that packet. At the sender side, timeout will occur, and sender will retransmit that packet. Means already traffic and retransmission mean created more congestion in the network. This is the main reason between the sender and destination, intermediate devices like router and the network is also the source of congestion occurrence. And TCP IP protocol have no criteria for the solution of this congestion. So at the transport layer, TCP will take care about this type of congestion. So TCP cannot ignore congestion in the network. This TCP will need to find some solution how this congestion gets solved, because if more retransmissions will occur, sometimes the duplicate packets will also arrive at the receiver side, and duplicate packets may be delivered to the process. So for all these solutions, and this congestion will not occur, TCP will come into a solution. That is means if we fix the size of the sender window, if we fix the size of the sender window, there may be some chances of the collision reductions. Means sender will send only the amount of data that is handled by the network as well as handled by the receiver TCP also. If both are able to handle that data, congestion will not occur in the intermediate network. Because of that one, TCP defined one term that is called the congestion window. TCP defined this term, this is called the congestion window. Congestion window is the window of the congestion or sent by the sender when a congestion is need to be controlled. Okay, the size of the sender window is controlled by the receiver, as we already seen that, and the actual sender window size is equal to the minimum of receiver window size, or you can say the advertised window by the receiver, advertisement window by the receiver, and this is the congestion window. This is the congestion window. Minimum of both is the actual sender window size. Actual sender window size. So for handling the congestion, we have these policies. Mainly three algorithms are given here. We give the name as AIMD algorithm. Additive increase, multiplicative decrease. Additive increase, multiplicative decrease. Multiplicative decrease. This is algorithm used for the congestion control, AIMD algorithm. Here we have mainly three policies. One is the slow start, second is the congestion avoidance, and third is the congestion detection, or we also call this one as the fast recovery. We also give one name to this one as the fast recovery. Let's see all these one by one, and we will see how the congestion is controlled at these particular policies or by these particular algorithms. Let's see first of all slow start. We also give the name to slow start as the exponential increase. Also give the name to the slow start as the exponential increase. Exponential increase means the size of the congestion window is always start with the 1. The size of the congestion window start with the 1 maximum segment size. We have maximum segment size, this is MSS, maximum segment size, that is allowed to send by the sender if sender is sending the data in the form of segments. Maximum segment size, and initially first point is here 1 segment. Congestion window will start with 1 MSS, and the size of this MSS may be anything. Let size of the MSS is equal to 1 KB or 2 KB or 4 KB, maybe any size of this MSS in kilobytes. How many number of bytes are present in that segment is the maximum segment size in the form of bytes. Okay, but it increases 1 MSS each time an acknowledgement arrives. An acknowledgement arrives. Mainly the sender start with the first congestion window is equal to 1 MSS, and the size will increase after a successful acknowledgement arrival. Congestion window is equal to congestion window plus 1. Actually this one is congestion window is equal to the old congestion window plus the congestion window, means both sign these are same. These are same. Let's see this one by an example. Initially start with the congestion window is equal to 1. Initially we start with the congestion window is equal to 1. Congestion window is equal to 1. Okay, is equal to 1. This one contain 1 MSS, and we send this one here. This one is sent by the sender. Okay, and received by the receiver. Receiver will send an acknowledgement. Received by the receiver. Receiver sends the acknowledgement. Acknowledgement. The time taken during this one is called the RTT. RTT, round trip time. This is a successful acknowledgement. Okay, this is the successful acknowledgement, and this is the segment sent with congestion window is equal to 1 MSS. After a successful arrival, here the congestion window is increased. Now the congestion window is equal to 2, means 1 is already plus 1 MSS is also, then this one become 2 MSS now. This one become 2 MSS now. This will contain 2 MSS. This will contain 2 MSS. This time we will send this one. We will send this one in this way. First segment is contain 1 MSS and the second is also contain 1 MSS, means two simultaneously, one by one, two subsequent segments are sent by the sender one by one. Okay, and this total size of this window is equal to 2. In the go back and protocol and a selective repeat protocol, we will send a segment, and if the congestion window is here 2 MSS, means we are sending two subsequent segments one by one or back to back, and we are waiting for the acknowledgement. After receiving of these, receiver will send two acknowledgements, and the time taken during this one means from here till here, from sending of the first segment to up to the acknowledgement of the second, time is called RTT, round trip time for the completion of this congestion window. Again we, some acknowledgement is arrived. Now again the size increase 2 MSS plus 2 MSS. Now the second is next congestion window size equal to 4 MSS. Now this time congestion window size equal to 4 ms, means now we have 4 segments 1, 2, 3 and 4, and these 4 segments are sent one by one by the sender and waiting for the acknowledgement. And after receiving of all the subsequent segments, receiver will send the particular acknowledgement, and the time taken for this completion is called the RTT. Means in a short, if I will tell you, every time an acknowledgement is arrived by the sender, the window size will be doubled. Means if an acknowledgement arrives, congestion window size gets doubled. Congestion window size gets doubled. Okay, here we will see one more thing. Up to how much window size this congestion window size gets doubled, means we need a threshold here. Up to that you will get doubled. After that, maybe the chances of congestion occurrence are more, you will go increase the size one by one or with some amount of time, not double every time. And here you see doubled means every time exponential increment is there. So for that we are using a threshold. Threshold means, for example, here we set initially the congestion window size equal to 1 MSS. For example, the window size, advertisement window size is 4 equal to 32 KB. Okay, and the congestion window size is equal to 16 KB. I'm taking this one a little example to teach you. And the window size and the sender window size is equal to the minimum of both advertisement window and the congestion window, means here this is equal to 16 KB. Then threshold is equal to, or we also call this one as the slow start threshold, and this one is equal to the sender window size by 2. If here this is 16 KB by 2, means the threshold is equal to 8 KB, means up to the 8 KB size, threshold is to stop the slow start phase. Up to the 8 KB congestion window size, we are increasing exponentially the size of the window. Up to last part, we increases the congestion window was equal to 4 MSS. In the last explanation, means we have 4 segments are there in the window, 4 1, 2, 3, 4 segments, and we sent all those 4 segments. After one by one, 4 segments are sent by the sender, and the acknowledgement was received, and the time taken for this was called RTT. Now, next time the congestion window is equal to 8. Next time the congestion window is equal to 8 MSS. Means in the congestion window we have 8 segments, 1, 2, 3, 4, 5, 6, 7, 8, and the sender will send these 8 segments one after one. 1, 2, 3, 4, 5, 6, 7 and 8, and acknowledgement is received from the receiver side, and acknowledgement are sent by the receiver. This way, but here you see this is reached to the threshold. Reached to the threshold means this exponential increment in the window size is up to the slow start threshold value. Is up to the threshold value. Means size of the congestion window increases exponentially until it reaches the threshold, and slow start phase is stop here. Means here the slow start phase it stops. Slow start phase stop here, and the next phase it starts. The next phase get start. Means slow start phase is saying that the first point is you will start the congestion initial window is equal to 1 MSS. Maybe the size of MSS, maybe 1 KB, 2 KB, 4 KB, 8 KB, anything. And after a successful acknowledgement arrival for that window, you are going to increase the size of window exponentially. Means every time on a acknowledgement arrival, the congestion window size is equal to doubled. First time 1, then second time 2, then third time 4, then fourth time 8. This increment is going up to the slow start threshold. After reaching the threshold, slow start phase will be stopped, and we are going to enter into the next phase. Okay, and the next phase is called the congestion avoidance phase. Let's see next phase, congestion avoidance phase. Congestion avoidance phase is saying when the size of the congestion window reaches the slow start phase, in the case, for example, anything. In the last we have given the sender window size is equal to how much? Up to the 16 KB, and the slow start threshold was equal to 8 KB. 8 KB. Here you reach. First of all, I will give you the general idea how this will increment it. After that, we will solve this one with the help of this particular example. For example, slow start threshold is equal to IMSS, and this one is stopped here. Slow start phase is stopped here. The next phase, the slow start phase is stopped here, and next phase is going to begins, and next phase is called the congestion avoidance phase, and we also call this one as the additive increasement phase. Here the congestion window increases additively. Additively means increased by 1 MSS. Not the double 1 MSS. Means if your congestion window is equal to congestion window plus 1 MSS, this way. Okay, or if we go through this formula, then this is the formula. After a successful arrival of an acknowledgement, congestion window size is increased equal to the congestion window size plus 1 by congestion window size. Means if congestion window size threshold is equal to I, then next time the congestion window size equal to I plus 1 MSS, and next time the congestion window size is equal to I plus 2 MSS. This way. If this is the threshold here. Last time the congestion window size was equal to 8. If we come here, for example, the congestion window size was equal to 8 MSS, and 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 8 MSS, and we send the 8 MSS. This time the congestion window size is equal to 8 plus 1, means equal to 9 MSS, and from here the congestion avoidance phase start. Congestion avoidance phase start. Avoidance phase starts, means now our congestion window contain 9 segment, 1 2 3 4 5 6 8 9, 1 2 3 4 5 6 7 8 9. Okay, 9, and we will send this window. We send this window, and this one contain 9 segments, 1 2 3 4 5 6 7 8 and 9 MSS. And for example, up to here this particular will send completely, and all the acknowledgements are received successfully, or we can also show this one with a single window size. With a single line we can also show that. For example, this window is completely sent, this congestion window is sent, and 9 MSSs are sent, and the acknowledgement is received from the receiver, and the time taken is called the RTT. Next time this is successfully received, on an acknowledgement arrival the congestion window size is going to increase, and this time increment is 1. 9 plus 1 is equal to 10 MSS. We send congestion window is equal to 10 MSS, and acknowledgement is come from the receiver side, and again this one is going to increase up to, this one is going to increase congestion window, last time 10, this time 1, equal to 11 MSS. 11 MSS, congestion window of 11 MSS is sent, and acknowledgement is from the receiver side. This one is going to increase up to how much? Congestion phase is going to increase up to the maximum sender window size. Maximum sender window size is how much here? 16 kilobytes, means up to 16 kilobytes. Up to the segment size is equal to 16 kilobyte, this congestion avoidance phase is going on, continuously going on. When our congestion window size is equal to 16 KB or 16 MSS, here 1 MSS is equal to 1 kilobyte, we taken 1 kilobyte, 16 KB or 16 MSS means 16 KB, and you sent this 16 KB MSS. From here you reached up to the maximum window size. Now you reached here up to maximum window size, and due to this one maybe the congestion chances are possible, maybe the congestion is possible, congestion is possible in the network, congestion occur, and continuously we are sending 16 KB 16 KB 16 KB one by one up to the congestion is not happened. Continuous up to congestion is not occurred, okay, and this phase is called the next phase, and in the next phase we are going to for the congestion detection phase. Let's go for the next phase, that is congestion detection phase. Third phase is called congestion detection phase. TCP sender react to the congestion detection in one of the two following ways. Last, congestion window is equal to 16 MSS, we sent 16 MSS and expect the acknowledgement, and again he is going to send the 16 MSS and up to the congestion is not occurred, acknowledgement is received. Here one chance is, two way the congestion may be possible. One, if a timeout is occur means, for example, here this 16 MSS is sent and this one is lost, this segment is lost, and the timer start from here, timer start here. If a segment is lost, then this means the very high congestion in the network. If a segment is lost, this means very high congestion in the network, and sender will not get any acknowledgement, and here the timeout expire, and till that no acknowledgement from the receiver side. Timeout expire is giving us the idea that there is a high congestion in the network, high congestion or strong congestion in the network, because packet loss may be occurred due to the router buffer capacity, or due to the collision of the packets, or due to maybe the high congestion in the network. This all things are giving us an idea that very high congestion is already present in the network. Here at this point, a new starting will be beginning. If a timeout is detected, the new slow start phase starts. Here we will set the new threshold value. And new threshold value is equal to the current sender window size. By 2. And current sender window size equal to 16 kilobyte by 2 means 8 KB. New threshold value is equal to 8 kilobytes. And from here the slow start phase will start. Restart transmission with slow start phase. And in slow start phase we are going to restart with 1 MSS, means here the congestion window is again equal to 1 MSS, and sender will send with 1 MSS size, and this is going up to the slow start threshold value. Okay, one point is here, when a timeout will occur, due to that timeout maybe the acknowledgement is lost is also a reason for that one. For example, this is the case of packet lost. I am discussing one more reason for this timeout now. For example, here the congestion window 16 MSS is sent, and second reason here, first reason was of the timeout is packet lost or the segment lost. Second reason I am discussing when acknowledgement is also lost. Maybe acknowledgement, you send the 16 MSS and timer start. Your receiver sends the acknowledgement, but this acknowledgement get lost in the network. And here timeout expires means the sender will assume that again there is a high congestion in the network. Timeout means this is a sign of high congestion in the network. Here also this is again the reason for the timeout. Means either timeout means either the packet is lost, either the acknowledgement is lost, means acknowledgement is not received before the timeout expires. Again the same reason is same criteria, means new threshold is set. New threshold is equal to current sender window size by 2. Sender window size is 16 MSS by 2 means is equal to 8 kilobytes. 8 kilobyte, and again we start with the slow start phase. Restart with the slow start phase, and in slow start phase, initial congestion window size equal to 1 MSS. We send this one with 1 MSS. Start with 1 MSS and receive the acknowledgement. Okay, received the acknowledgement. This is the way when fast recovery is done. Fast recovery is done, and congestion will occur, and due to that congestion, either the packet is lost, either the acknowledgement is lost. In both cases, when timeout is occur at the sender side, we will set the new threshold, and that new threshold is equal to the current window size by 2, and we will restart the transmission with the slow start phase. We will restart transmission with the slow start phase. Okay, for example, here we start with the slow start phase. Okay, and the congestion window is sent equal to 1. Congestion window is sent equal to 1 MSS, and slow start threshold is equal to 8 kilobyte or 8 MSS, and 1 MSS is done. 1 MSS sent, acknowledgement received, window size equal to this time 2 MSS. This 2 MSS is sent. This 2 MSS is sent. In this 2 MSS, we send this one and we send this one, and the acknowledgements are received. Acknowledgements are received. Now the congestion window size is equal to 4 MSS. Congestion window size equal to 4 MSS, and you send the 4 segments. First segment get lost. In this case, first segment get lost. Second segment is received successfully. Third segment is received successfully, and fourth segment is received successfully. These all 3 segments are received successfully, but this segment, first segment of the congestion window 4 MSS is equal to lost. Then acknowledgement come here. Acknowledgement is received by the sender. For example, its sequence number is equal to 100. I'm taking example, and the sequence number of this one is equal to 200, and sequence number of this one is equal to 300, and sequence number of this one is equal to 400. Sender send the acknowledgement here. Acknowledgement number is equal to 100. Second, not received means in the buffer, first one is not received, 200 is received successfully, sent again the acknowledgement number is equal to 100 again. Third one is received successfully, 300 is done, acknowledgement number is again 100. Next 400 sequence number is again, means all are out of order packets are received or out of order segments are received, again send the acknowledgement number is equal to 100. Means one is the original acknowledgement here, this one is the original acknowledgement, and these 3 are the duplicate acknowledgement. 3 duplicate acknowledgements are received. Okay, because this number 100 is not received by the sender, that one is lost in the particular network, or maybe the corrupted received. Maybe any 2 cases come, any 2 reasons comes. First reason may be the segment lost. And second reason may be here corrupted packet loss, corrupt segment received, maybe any 2 reasons. Due to that, sender is accepting the next subsequent segments and put all them in the buffer, okay. Due to this one, a chances of 3 duplicate acknowledgement is possible, and when 3 duplicate acknowledgement are received, this received by the sender means there is no congestion in the network up to a high level, means low congestion. High congestion is not present here, there is a weak congestion in the network. Because of that one, if high congestion is there, even the chances of acknowledgement lost is also possible. Okay, but all the four acknowledgement are received successfully means there is a low congestion or weak congestion in the network. When this one is see three duplicate acknowledgements, the new threshold is set here. New threshold is set here. New threshold, and new threshold is equal to current sender window size by 2. Current sender window size is how much? 4 MSS. 4 MSS by 2, and this is equal to 2 MSS is the next new threshold. And we will start here with the congestion avoidance phase. When three duplicate acknowledgements occur, we will start with the congestion avoidance phase. Okay, congestion avoidance phase. Congestion avoidance phase. Okay, congestion avoidance phase. So this is done. So here this way we are solving the problem of this. New threshold is done. Now we will start with the congestion avoidance phase, and in congestion avoidance phase we know the congestion window is increasing additively. Additively means if this is 2 MSS, if threshold equal to 2 MSS, the next window is equal to congestion window is equal to additively means 2 plus 1 equal to 3 MSS, and this one is going up to the maximum sender window size value. Maximum sender window size value. Congestion avoidance phase is additively increased from the threshold and going up to increment, additive increment up to the maximum sender window size. And during that, if anything occur, either the timeout will occur or either the three duplicate acknowledgement will occur, then we again going to start with the new threshold. So this is congestion detection phase. Congestion detection phase means we will detect the congestion by two things. Either the timeout will occur at the sender side. Timeout occur maybe because of two reasons. Either the segment is lost, either the acknowledgement is lost. And if lost will occur, that this means that there is a high congestion in the network. And in the case of timeout occur, we will set the new threshold and restart the transmission with the slow start phase. Second is congestion detection method is the three duplicate acknowledgement. If a segment is lost from the congestion window, the receiver will send acknowledgement for the expected segment and accept all the out of order segments in the buffer and send the acknowledgement for the lost or the corrupted segment. When the sender will receive three duplicate acknowledgement, means all the three duplicate acknowledgement are passed through the network and received successfully by the sender. This is the sign of the weak congestion in the network. And due to this weak congestion, we will set the new threshold, and the new threshold is again equal to the current sender window size by 2. And retransmission will start with the congestion avoidance phase. And this phase is increased additively up to the maximum sender window size. And this is the main reason for the congestion detection. Congestion detection may be or the timeout may be occur in any of the three phases. Any of the three phases of the transmission. In the slow start phase also the congestion occurrence is possible due to timeout or three duplicate acknowledgement. In the congestion avoidance phase also there are chances of timeout occurrence or maybe the three duplicate acknowledgement, and in the congestion detection phase also maybe the chances of timeout occur or the three duplicate acknowledgements. Congestion detection is the main method to detect the congestion in the network, and that congestion may be the high congestion or maybe the weak congestion. Okay, this is mainly about the congestion